chào các con. Vừa qua thì chúng ta đã vừa tìm hiểu chương 2, cấu trúc của tế bào. Giờ chúng ta sẽ chuyển sang chương 3, chuyển hóa vật chất và năng lượng trong tế bào. Trước tiên chúng ta sẽ tìm hiểu về bài 13, khái quát về năng lượng và chuyển hóa vật chất. Năng lượng và các dạng năng lượng trong tế bào. Về khái niệm năng lượng thì được định nghĩa đó là khả năng sinh công. Thì gồm có hai loại, đó là động năng và thế năng. Động năng là dạng năng lượng sẵn sàng sinh ra công. Thế năng là cái dạng năng lượng dự trữ, có tiềm năng sinh công. Và năng lượng chủ yếu trong tế bào là hóa năng. Đây là loại năng lượng mà tiềm ẩn trong các liên kết hóa học. Vậy thì để hiểu rõ hơn về động năng và thế năng thì các con hãy theo dõi video sau.
And over here in this third old drawing of this person doing a handstand dive, this is probably the most typical example of potential energy being converted into kinetic energy that you might find in a physics textbook. Over here at the top of the diving board, this gentleman has potential energy by virtue of his position. And over here it's very clear he has the potential to fall and has the potential to turn it into kinetic energy. And so once he falls over, at this point, most of his potential energy has been converted into kinetic energy. So here it's potential, and here it is kinetic energy. So the big takeaway is energy, it's the ability to do work. It cannot be created or destroyed, but it can be converted from one form to another. And all of the forms, at the end, at their essence, you can really think about them in two big buckets. You can think about them as potential energy or kinetic energy or kinetic energy. And as a last example, you might say, well, how can this guy do work? Well, you can imagine if there was some type of system here, where we'd create some machinery. Maybe there's a pulley right over here, and then it's lifting a weight right over here. Well, if he jumped on this, he won't fall down as fast. But then as long as he's heavier than this weight, it's going to pull this down, and then this weight is going to go up. So he has the potential to do work by virtue of his position. There just isn't this pulley system there to get that actual work done.
Tiếp theo chúng ta sẽ tìm hiểu về ATP. ATP là một hợp chất cao năng và được xem như là đồng tiền năng lượng của tế bào. Về thành phần thì gồm có 3 giơ nitơ adenine, đường ribose và 3 nhóm phốt phát. Cơ chế chuyển năng lượng của ATP thì đầu tiên sẽ chuyển nhóm phốt phát cuối cùng cho các chất để trở thành ADP, và ngay lập tức thì ADP này sẽ được gắn thêm một nhóm phốt phát để trở thành ATP. Về chức năng, thứ nhất đó là tổng hợp nên các chất hóa học cần thiết cho tế bào. Thứ hai đó là vận chuyển các chất qua màng, và thứ ba đó là sinh công cơ học. Vậy thì để tìm hiểu rõ hơn về thành phần cũng như cả cơ chế chuyển năng lượng và chức năng của ATP thì mời các con theo dõi video sau.
Oh, hello there. I'm at the gym. I don't know why you're here, but I'm going to do some push-ups, so you can join me on the floor if you want.
Now, I'm not doing this just to show off or anything. I'm actually doing this for science, okay? Ugh. You see what happened there?
My arms moved, my shoulders moved, my back and stomach muscles moved, my heart pumped blood to all those different places. It's pretty neat, huh?
Well, it turns out that how we make and use energy is a lot like sports or other kinds of exercise. It can be hard work and a little bit complicated, but if you do it right, it comes with some tremendous payoffs. But unlike hitting a ball with a stick, it's so marvelously complicated and awesome that we're still unraveling the mysteries of how it all works. And it all starts with a marvelous molecule that is one of your best friends, ATP. Today I'm talking about the energy and the process our cells and other animal cells go through to provide themselves with power. Cellular respiration is how we derive energy from the food that we eat, specifically from glucose, since most of what we eat ends up as glucose. Here's the chemical formula for one molecule of glucose. In order to turn this glucose into energy, we're going to need to add some oxygen, 6 molecules of it to be exact. Through cellular respiration, we're going to turn that glucose and oxygen into 6 molecules of CO2, 6 molecules of water, and some energy that we can use for doing all of our push-ups. So that's all well and good, but here's the thing. We can't just use that energy to run a marathon or something. First, our bodies have to turn that energy into a really specific form of stored energy called ATP, or adenosine triphosphate. You've heard me talk about this before. People often refer to ATP as the currency of biological energy. Think of it as an American dollar. It's what you need to do business in the US. You can't just walk into a Best Buy with a handful of Chinese yen or Indian rupees and expect to be able to buy anything with them, even though they're technically our money. Same goes with energy. In order to be able to use it, our cells need energy to be transferred into adenosine triphosphate to be able to grow, move, create electrical impulses in our nerves and brains, everything. A while back, for instance, we talked about how cells use ATP to transport some kinds of materials in and out of its membranes. To jog your memory about that, you can watch that episode right here. Now, before we see how ATP is actually put together, let's look at how cells can cash in on the energy that's stashed in there. Well, adenosine triphosphate is made up of a nitrogenous base called adenine with a sugar called ribose and 3 phosphate groups attached to it. Now, one thing you need to know about these 3 phosphate groups is that they are super uncomfortable sitting together in a row like that, like 3 kids on a bus who hate each other all sharing the same seat. So because the phosphate groups are such terrible company for each other, ATP is able to do this nifty trick where it shoots one of the phosphate groups off the end of the seat, creating ADP, or adenosine diphosphate, because now there are just 2 kids sitting on the bus seat. In this reaction, when the 3rd jerk kid is kicked off the seat, energy is released. And since there are a lot of water molecules just floating around nearby, an OH pairing, that's called a hydroxide, from one of the H2Os comes over and takes the place of that 3rd phosphate group, and everybody is much happier. By the way, when you use water to break down a compound like this, it's called hydrolysis, hydro from water and lysis from the Greek word for separate. So now that you know how ATP is spent, let's see how it is minted nice and new by cellular respiration. Like I said, it
ATP, or adenosine triphosphate, is often referred to as the currency of energy, or the energy store, adenosine, the energy store in biological systems. And what I want to do in this video is get a better appreciation of why that is. So adenosine triphosphate. So at first, this seems like a fairly complicated term, adenosine triphosphate, and even when we look at its molecular structure, it seems quite involved. But if we break it down into its constituent parts, it becomes a little bit more understandable, and we'll begin to appreciate how it is a store of energy in biological systems. So the first part is to break down this molecule between the part that is adenosine and the part that is the triphosphates, or the 3 phosphoryl groups. So the adenosine is this part of the molecule. Let me do it in that same color. So this part right over here is adenosine, and it's an adenine with connected to a ribose right over there. So that's the adenosine part. And then you have 3 phosphoryl groups, and when they break off, they can turn into a phosphate. And so the triphosphate part, you have, so triphosphate, you have 1 phosphoryl group, 2 phosphoryl groups, 2 phosphoryl groups, and 3 phosphoryl groups. So one way that you can conceptualize this molecule, which will make it a little bit easier to understand how it's a store of energy in biological systems, is to represent this whole adenosine group. Let's just represent that as an A. Actually, let's make it that an AD. And then let's just show it bonded to the 3 phosphoryl groups. So, and I'll make those with a P and a circle around it. So you could do it like that. Or sometimes you'll see it actually depicted, instead of just drawing these straight horizontal lines, you'll see it depicted with essentially higher energy bonds. So you'll see something like that to show that these bonds have a lot of energy. But I'll just do it this way for the sake of this video. But these are high energy bonds. Now, what does that mean? What does that mean that these are high energy bonds? It means that the electrons in this bond are in a high energy state. And if somehow this bond could be broken, these electrons are going to go into a more comfortable state, into a lower energy state. And as they go from a higher energy state into a lower, more comfortable energy state, they are going to release energy. One way to think about it is if I'm about to if I'm in a plane and I'm about to jump out, I'm at a high energy state. I have a high potential energy. I just have to do a little thing and I'm going to fall through, I'm going to fall down. And as I fall down, I can release energy. There will be friction with the air, or eventually when I guess hit the ground, that will release energy. I could compress a spring, or I could move a turbine, or who knows what I could do. But then when I'm sitting on my couch, then I'm at a low energy state. I'm comfortable. It's not obvious, how I can go to a lower energy state. I guess I could fall asleep or something like that. And these metaphors break down at some point. But that's one way to think about what's going on here. The electrons in this bond, if you can give them just the right circumstances, they can come out of that bond and go into a lower energy state and release energy. So one way to think about it, you start with ATP, adenosine triphosphate, and one possibility, you put it in the presence of water, and then hydrolysis will take place. And what you're going to end up with is one of these things are going to be essentially, one of these phosphoryl groups are going to be popped off and turn into a phosphate molecule. And so you're going to have then adenosine. Since you don't have 3 phosphoryl groups anymore, you're only going to have 2 phosphoryl groups. You're going to have adenosine diphosphate, often known as ADP. Actually, let me write this down. This is ATP. This is ATP right over here. And this right over here is ADP, di for 2 phosphoryl groups, adenosine diphosphate. And then this one got plucked off. This one gets plucked off, or it pops off, and it's now bonded to the oxygen and one of the hydrogens from the water molecule. And then you could have another hydrogen proton. But the really important part of this I have not drawn yet. The really important part of it, as the electrons in this bond right over here go into a lower energy state, they are going to release energy. So plus energy. So here, this side of the reaction, energy released. And this side of the reaction, you see energy stored. And so as you study biochemistry, you will see time and time again energy being used in order to go from ADP and a phosphate to ADP. So that stores the energy. You'll see that in things like photosynthesis, where you use light energy to eventually get to a point where this P is put back on, using energy, putting this P back onto the ADP to get ATP. And then you'll see when biological systems need to use energy, that they'll use the ATP, and they'll essentially hydrolysis will take place, and they'll release that energy. Sometimes that energy could be used just to generate heat, and sometimes it can be used to actually forward some other reaction, or change the conformation of a protein somehow. Whatever might be the case.
Tiếp theo chúng ta sẽ tìm hiểu về chuyển hóa vật chất. Trên đây chính là cái sơ đồ về chuyển hóa vật chất và năng lượng trong tế bào của cơ thể. Những chất như là protein, glucid, lipid sẽ được đưa vào cơ thể qua thức ăn. Qua cái quá trình tiêu hóa sẽ tạo ra những axit amin, glucose và axit béo. Từ đây thì quá trình chuyển hóa bên trong tế bào thì bắt đầu diễn ra qua một loạt những cái phản ứng sinh hóa phức tạp. Sản phẩm của quá trình này sẽ giúp cho tế bào thực hiện các đặc tính đặc trưng khác nhau cơ bản của sự sống, như là sinh trưởng, cảm ứng và sinh sản. Đặc điểm của quá trình đó là chuyển hóa vật chất thì luôn đi kèm với lại chuyển hóa về năng lượng. Chuyển hóa vật chất thì bao gồm có 2 mặt, đồng hóa và dị hóa. Đồng hóa là tổng hợp các chất hữu cơ phức tạp từ các chất đơn giản. Dị hóa là phân giải các chất hữu cơ phức tạp thành các chất đơn giản. Quá trình dị hóa sẽ cung cấp năng lượng để tổng hợp ATP từ ADP. Và ngay lập tức thì ATP này sẽ phân hủy thành ADP, đồng thời sẽ giải phóng ra năng lượng để dùng cho quá trình đồng hóa và các hoạt động sống khác của tế bào.